Hello, for today we will be talking about the future value of ordinary annuity. Annuity is defined as a series of fixed payment made at equal intervals at a specific period. Usually, annuities are used on regular deposits on saving accounts, also on home mortgage payments, insurance payments, pension payments, car loans, and appliance loans. In an ordinary annuity, all the payments are made at the end of each period. As shown on this cash flow, the first payment is at the end of the first period, then followed by the end of the second period, third period, until the nth period. After the last payment, the future value here is the total amount of all these payments. P is the present value of the annuity, F is the future value, and R is the periodic payments or the cash flow per period in this case. The future value of an ordinary annuity is the total value of all the payments at a specific point in time. Here we use the formula F is equal to R, the quantity 1 plus j raised to the power of n minus 1 all over j, or j is I over m, and n is equal to mt. F is the sum of the accumulated values of all the payments at the end of n periods. R is the periodic payment, I is the periodic rate, M is the number of compounding periods per year, and T is the number of years. Let us try to illustrate this given example. An investor deposits 500 pesos for 5 years in an account that earns interest at the rate of 8% per year, compounded semi-annually. So how much will be in the account immediately after the last payment? First, we try to recognize what the given here are. Of course, we have your R is equal to 500 pesos. Then we have your I is equal to 8%, or this is basically equal to 0.08. Your time here is 5 years. And your M is 2, because it says here the compounding is semi-annually. So we could say that your J is equal to I over M, or that is equal to 8%, 0.08 divided by 2, or that is equal to 0.04. And we also have here your N is equal to 2 times of T, or that is equal to 10. And so from our given cash flow, you would be able to see that there are 10 periods in this case. 1, 2, 3, and then so on and so forth until the 10th. And each period would be 500 pesos each. Looking into this diagram, the first payment would be when your time is n minus 1, or that is 9. And then the second will be 8, the third will be 7, and so on and so forth until the last payment, which is equal to 500 without interest. The amount F of the annuity is the sum of all these 10 amounts. Take note that this is a geometric series which could be illustrated as follows. A sub 1 is equal to 500. Your R, or the common ratio, is 1.04, and N is equal to 10. By evaluation, we substitute your 500 with A sub 1 and your R with 1.04, and of course your 10 to your N. We will be able to get approximately equal to 6,003 pesos and 5 centavos. Therefore, the amount in the account after the last payment is 6,003 pesos and 5 centavos. Basically, the annuity is just simply the summation of all the amounts R times 1 plus j, R times 1 plus j squared, plus R times 1 plus j cubed, and so on and so forth until R times 1 plus j raised to the n minus 1 power. And since this is a geometric sequence, partial formula substituted by R 1 plus j and n, then we will yield to this formula. Now take note that this is cancelled, and so this is going to become negative j. And finally, making this positive, we interchange 1 and 1 plus j raised to n. Simplifying further, we have f is equal to r times the quantity 1 plus j raised to the n power minus 1 all over j, which is the formula for your future value. So if we go back to our example here and we use the formula to find out what the future value is equal to, then it is the same value as the value we got from our first computation. So let's go ahead and answer the following given examples. Suppose Mark wishes to save 3,000 in a mutual fund that gives 2.5% compounded semi-annually. Determine the future value of his savings after 10 years. So in this case, we are going to consider the given R is equal to 3,000, the periodic payment. We have your I is 2.5% and your R time is 10 years. And you have the compounding period, we have M is equal to 2 since it talks about semi-annual compounding. Then we're gonna find for J, we have J equals I over M. So 0.25 divided by 2. So this is equal to 0.0125. Then N is equal to M T, we have 2 times 10, so we have 20 years. Using the formula, F is equal to R times 1 plus J raised to the n minus 1 divided by J. So we try to substitute the given. We have your R is 3,000 and 1 plus J is 1. This is going to be plus 0.0125 raised to the power of 20 minus 1. This is divided by J 0.0125. Let's go ahead and try to calculate this one. We will use our calculator. We have 3,000. We have 3,000 times. Let's go ahead and type in all these ones. So we could have this one combined with 0.0125. So we have 1.0125. And let us have this raised to the 20th power. The exponent is 20. Then subtract 1. And then here is your J, which is equal to 0.0125. You put 0 if you wish to, but that's not necessary. And then we enclose this with parentheses. And so we are able to get 67,688.94, or that would be equal to 67,688 pesos and 94 centavos. So that answers our question. Determine the future value of Mark's savings after 10 years. And this is the future value. So let's move ahead with the second example. To the second example, we have find the value of. So let's move on to this second example. Find the future value. Find the future value of 2,500 pesos payable every 3 months for 8 years. The money is worth 6%. Let's go ahead and have the given R is equal to 2,500 because we're going to look for the future value. Interest rate is 6%. Time given is 8 years. And the compounding period is every 3 months. That means it is quarterly. And find for J, it's equal to I. We find for J, that's I over M, are equal to 0.06 divided by 4, or F is equal to 1.5%, or 0.015. Next, go ahead and look for your N, which is empty. Our M here is 4 multiplied by 8, and that is equal to 32. Now we input all this to our formula. F is equal to R times the quantity. We have 1 plus J raised to the power of N minus 1 divided by J. We have R is equal to 2,500. So we have our R is equal to 2,500. Then we multiply this by 1 plus J. Our J is 1, 0.015 raised to the power of N. It's 32 minus 1. Let's go ahead and write the denominator 0.015, and we may have this input on your calculator. Go ahead and change this. So we have 2,500 multiplied by 1. Let's just combine 1 and 0.015 to, and we've got 1.015. Then it's going to be raised to the 32nd power. Subtract 1. Denominator 0.015. And go ahead and pesos. So we've got 101,720 pesos and 72 centavos. We write this. And this is also the future value, just like your first example. So let us now answer our third example. How much money should be invested every month at 12% per year, compounded monthly, in order to have 4,000 in 18 months? Take note that the given here is the future value, and we're going to look for R, which is the one unknown. Since we're looking for how much money that must be invested, so your R is the one which we're going to look for. Therefore, your 4,000 here is the future value. F is equal to 4,000 pesos. The interest rate is 12%. Time is given as 18 months. Or this is simply equal to 1.5 years. M is equal to 12. since our compounding period is monthly. Then of course we have your J is equal to 12%, 0.12 divided by 12, or that is this is equal to 0.01, which is equal to 12 times 1.5, or that is simply equal to 18. Going over our formula, we have F is equal to R times the quantity 1 plus J raised to the n minus 1 divided by J. But since we are going to look for R here, we make use of the formula R is equal to Fj divided by 1 plus J raised to the n minus 1. And so by substituting the formula with our given, our F is 4,000 to be multiplied by 0.01, and we have here your 1 plus J, or that is simply equal to 1 plus 0.01 raised to the 18th power minus 1. Or we could just simply have this 40,000 times 0.01 as 40, and the denominator would simply be 1.01 raised to the 18th power minus 1. And we could simply input this in our calculator to find out for the value. You have 40 divided by the quantity 1.01. Oops, this is 1.01 raised to the power of 18, and then this is minus 1. So we've got 203.93. We write this 203 pesos and 93 centavos. And this value is what we call your periodic payment. That is the amount of money that must be invested every month at 12% interest per year in a period of 18 months or 18 payments. Let us move on to our fourth and last example. How much total deposit must be made for 5 years and 6 months in order to accumulate 120,000 at 15% compounded quarterly? Now here, similar to our third example, we are also going to look for the unknown value, or your R. And then later on, after we are able to find R, we multiply that with the total compounding periods to find out how much the total deposit is after 5 years and 6 months. So since our R is unknown here, our F must be 120,000. I'm sorry, this must be 120,000. And your I is 15%. Let's go ahead and write everything here. Your T is 5 years and 6 months. And this is actually 5.5 years. We're gonna use this one in our formula, where M here is 4 since it's compounded quarterly. Then we got your J is 15% divided by 4, or that is actually equal to 0.0375, and our N here is 4 times 5.5, or that is 22. We will now substitute all this given to our formula. We use the same formula that we have used earlier in our third example. We have R is equal to F times J multiplied by 1 plus J raised to the n minus 1. And we have our f is equal to 120,000 to be multiplied by our j, which is 0.0375. And we divide this by 1. So we may just simply combine this one. 1 plus j is 1 plus 0.0375, or simply 1.0375. The exponent here is 22, so that we could simply input this in our calculators easily. 120,000 will be multiplied by 0.0375. Then we input the denominator. We have 1.0375 raised to the exponent 22 minus 1, and we get the amount 3,606 and 64 centavos. Write it down. 3,606 and 64 centavos. So this is going to be our periodic payment. Okay. But we have still to look for the total deposit that would be made after 5 years and 6 months. We multiply this now by the number of periodic payments, number of periods of payments rather, that is 22. And we just simply multiply this by 22. And we have 79,364 pesos. So we were able to get the total amount, which is equal to 79,364. This is your total deposit. So that's just about it. This is how we apply our future value in the given examples. Thank you.